What's the farthest galaxy we've seen with James Webb? What's the maximum speed possible to achieve with gravitational slingshots? Is lunar Starship destined to topple? And in Q&A Plus, how many interstellar objects have we missed? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are, across my channel, the question pops in your brain. Just write it down. I'll gather them up and I will answer them here. And here is in Thailand. We're in Bangkok for a couple more days before we get out of the city and start to get out into the nature, which is really the plan. Temples, animals. So, yeah, let's get into the questions. Andrew Drs Williamson YT. What is the furthest galaxy that we know of after Webb took over from Hubble? So when Webb came online, it was immediately setting records for the most distant galaxies in the universe. The early days, if you can remember back, sort of summer of 2022, wow, we were getting these distances. Now, astronomers measure distance using a term called redshift, and the cosmic microwave background radiation is 1000 redshift, and then the numbers come down from there. And we were getting numbers from James Webb reporting things in the 10 redshift to 15 plus, even 17 redshift. Essentially, you're seeing the galaxy within between sort of 200 million years after the Big Bang to 400 million years after the Big Bang. Now, that was a very rough measurement that was made, and then astronomers got more time on James Webb, and they were able to do sort of deeper follow-on observations and confirm the spectra of the galaxies. And the spectra is the thing you need. It's looking at the light of the galaxy to tell you, you're essentially seeing how the various absorption lines and emission lines of the galaxy are being shifted into the red side of the spectrum. It's this chemical fingerprint. And once you can measure that chemical fingerprint, and then you see how far it's been shifted, you can calculate essentially how fast that galaxy is moving away from you, the redshift. And from the redshift, you can calculate the age of the universe that you're seeing that galaxy. And the record right now, and of course this is September 2025, is a galaxy called JWST 14. So the name there is that it's a redshift 14 object. And the JADES is that it was gathered as part of the JADES survey, the James Webb Advanced Deep Extragalactic Survey. And so when you convert the redshift of, it's 14.18, when you convert the redshift of 14.18 to years after the Big Bang, you get about 300 million years after the Big Bang. I think it's like 290 million years after the Big Bang. And so right now, that is the oldest galaxy that we know of. But we're still sort of pre-James Webb Deep Field Survey. Webb is doing this survey, the JADE survey. There are other surveys that they're doing, but they haven't gone and done what they did with Hubble, where they pointed a spot in the sky that is seemingly empty and then just gather photons for hours, days, maybe weeks, and then use that to then sort of study what you see in that small area. And so almost certainly that record of 290-ish million years after the Big Bang is going to get broken in the future. The other way, and this will be sort of even luckier, is if there is a gravitational lens. So you can have the situation where there is a foreground galaxy or a galaxy cluster that is acting like a natural telescope lens to some object that is behind. And Webb has observed a ton of these, but out there somewhere, there's going to be the perfect lens where you've got this foreground object that is lensing this other object behind it that is much farther away. Now, there's going to be a limit to how far away you can see galaxies, because that there's this sort of time in the universe called the Dark Ages, where the universe was essentially opaque. It was sort of filled with fog. And that even if there were galaxies that were forming, they were surrounded by this fog that didn't let any of its light escape. And so we wouldn't be able to see it. So we will reach this point where we will find the farthest possible galaxy, and it will be some number. And we're not there yet, not there today, but I would say by the time Webb has reached the end of its life, there will be this number. It will be the farthest galaxy that we've ever seen. It will probably stand as a record for the test of time, and it will pretty much be the farthest
galaxy we possibly can see, because we can't see through the dark ages. The entire universe was like this really thick fog. And so we won't be able to see through it using a telescope like James Webb. Now, there's other ways to look through that dense fog, but maybe that's a different video. Zammer Z, could a gravitational slingshot be possible to exceed the speed of light, like a black hole slingshot versus a star slingshot? So, like, rule number 1 is that you cannot go faster than the speed of light. Rule number 2, read rule number 1. Refer to rule number 1. So you can't go faster than the speed of light. So even if you could receive an almost infinite amount of energy from your gravitational slingshot of a black hole, you can't go faster than the speed of light. What you'll do instead is you will be putting an infinite amount of energy into your acceleration, and you will get closer and closer to the speed of light, and it will take an infinite amount of energy to get you all the way up to the speed of light. That's just the iron law of the universe. And so there's no idea that you can use that will allow you to go faster than the speed of light. Like, unless we figure out a warp drive, no, you could burn all of the fuel, all of the hydrogen in the entire universe in one big fusion drive, and you won't go faster than the speed of light. You could turn all of the universe into antimatter, and then, or half of it into antimatter, and then combine that antimatter with matter, and you're not going to be able to go faster than the speed of light. And you could do a gravitational slingshot around the most supermassive black hole, ton 618 or whatever, and you won't go faster than the speed of light. You go very fast, though. You can go very close to the speed of light, but you can't go faster. And, we have particle accelerators here on Earth where they are accelerating protons to 99.9999, some huge number of % the speed of light, that those protons are experiencing time dilation in the particle accelerators, but they can't go faster than the speed of light. Like, you can't accelerate a single proton faster than the speed of light, even if you use all of the energy available in the entire universe. You're still going to go slower than the speed of light. It's going to be very close, but that's the rule.
It's time to shout out our new patrons at the $5 level and above. E. Eliashar, Katie Byrne, Don Cross, Ben Diedrich, Ionic Decay, Trevor Waters, Dagar, Andrew Brown, Vitali, and Jason Smith. Join our community at patreon.com/universetoday.
Homestead Paradise. Hello there, fellow Canadian, longtime listener, first-time questioner. How are humans going to survive the radiation emitted by the sun when we inevitably leave to explore Mars? So we know that when you go to space, you are experiencing a couple of 100 times as much radiation as when you're experiencing down here on Earth. We are protected by the magnetosphere. We're protected by the atmosphere. Once you leave the protection of that, then you are just experiencing that radiation. And the radiation from the sun is a problem, especially if there's a solar storm. You can experience enough in a really powerful solar storm to get a lethal dose of radiation, and you just die. So when you think about some of the really powerful solar storms, when we see these really cool auroras in the sky, when we see these incredible flares and coronal mass ejections coming off the sun, those could be lethal to astronauts. But the more insidious one is the cosmic rays, because they are nonstop. So you don't have to sort of time things. They're just happening all the time. And the energy from the cosmic rays are much higher than the energy coming from the radiation particles that are coming from the sun. And so there are different ways to mitigate both of these. The solar storms, the plan is to build a fort. In the Orion capsule, the astronauts have a whole bunch of material that they can use. They have water, they have food, they have all kinds of scientific equipment, and that they have been trained to create a protective area inside the Orion capsule to protect them from a solar storm, to decrease the radiation load that they're experiencing while this solar storm is happening. But the cosmic rays, there's no way to stop them. With the amount of stuff that you have available, you just are experiencing this constant damage to your DNA from the cosmic rays. And that will sort of inevitably lead to higher rates of cancer down the road. So what can be done about it? Well, the only solution is that you have to put a lot of protons between you and the radiation, about 1 meter of protons. So 1 meter of water, 1 meter of rock, 1 meter of metal, whatever you want, Just get that material in between you and space. And the problem is those things are very heavy, that, if you want to surround your spacecraft in a shell that is a meter thick of water or rock or metal, then that's an enormous amount of weight that you're having to then accelerate. When you consider if the Orion capsule weighs, I don't know, 15 tons, I don't know exactly what it weighs, around that, 10 tons, 15 tons, 20 tons. Anyway, you'll be looking at hundreds of tons more to surround yourself with water. So the plan is that there is no plan. The plan is that the people who are going to be the first human explorers to Mars are going to be brave explorers who are going to be subjecting their bodies to large amounts of radiation and are hopefully going to be rolling the dice and not getting large amounts of cancer down the road, are hopefully not going to experience a lot of solar storms that also give them acute radiation poisoning. Space is hard and dangerous and scary, and that we need to understand that anyone who is willing to make that journey is going to be taking an enormous risk. But for a lot of people, that's totally worth it. They don't, cancer is future me's problem, not today me's problem. So off to Mars we go. Pizznops, can satellites be seen with the naked eye? Absolutely. If you live in dark skies, I live in dark skies, and you go out any night and right away you're like, satellite, satellite, satellite. Generally they're very dim. But the International Space Station is incredibly bright. It's as bright as Venus. It's like the brightest object in the sky after the sun and the moon. And you can't miss it. You can see it in super light polluted cities. So what I would recommend that you do is there's websites that'll tell you when the International Space Station is going to do a flyover of your area. And, depending on where you live, how much far north or south, it's visible from a huge chunk of the Earth. And you go outside, it's like a magic trick. You're like, hey, everybody, want to see a magic trick? There's the International Space Station. And then it just, we'll see it in 1 minute. And then the space station comes over the horizon and goes across the entire sky. It takes about a minute to go all the way across the sky. And it's very bright. So in darker skies, you can absolutely see satellites, lots of them. I remember as a little kid watching satellites. And at some point, it sort of switched from this is really cool to these are stupid things that are getting into my astrophotos. K.S. Albrecht 88. What is the theoretical timeline for the universe to expand to the point where all external galaxies and their light become permanently unreachable and invisible from any local point of view? So the universe is becoming less dense over time. The distances between galaxies is increasing. And there will come a time in the future when galaxies will fall over the cosmic horizon and redshift away and be harder and harder to see. Now, there won't be some specific date that this is going to happen. Right now, the reachable universe is only about 4% of the universe, and that number is getting less and less over time. So there will be some time when the only universe that we can reach is our local group, Andromeda, M33, a few hundred dwarf galaxies, the Milky Way. That's it. Everything else will be accelerating away from us too fast for even if we travel at the speed of light, we couldn't reach them. And so, I've heard the number like 100 billion years thrown around quite a bit. So in 100 billion years or so, you'll be an astronomer and you go outside and there are no other galaxies in the sky. There's just the local group. Now, those galaxies are just still there, and if you have like a really powerful telescope, you can probably still detect them, or if you have a radio telescope, you can probably detect them for 1 trillion years. But when you think about how, there will be stars that will live for 10 trillion years. So there's stars here in the Milky Way that will definitely outlive the time when all of the galaxies fall over the cosmic horizon and disappear. And future astronomers won't know of when the beginning of the universe happened, because that history will have fallen over the cosmic horizon. J. Lambert, given that the moon has much lower gravity and 2 landers have already toppled over, what is SpaceX's current design for its lander, and does it take into account how tippy things are on lower gravity? Their plan is to not fall over. Their plan is to be very careful. Their plan is to engineer their lander so that it doesn't have a problem, that it's a very tall, very top-heavy well, I mean, who knows how top heavy it's going to be. Maybe all the fuel's going to be down at the bottom and it'll be, more bottom heavy. but it's going to have little legs that are going to pop out the bottom of the rocket. And hopefully, unless there's like, it should land very carefully on the flattest place that it can find. They'll research the landing site carefully, and then hopefully it will land. But yeah, it seems like it would be, seeing how, various landers have already fallen over, they better be very, very careful.
Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question, how many interstellar objects have we missed? I'll put a link in the show notes. All right, those are all the questions that we had this week. Thank you everyone who asked your questions in the comments, everyone who joined me for the live show that this was filmed. Now, we didn't do a live show this week, so we've sort of pulled this together from previous weeks. But hopefully I'm going to try to do a live stream while I'm here in Thailand, but it all just depends on the internet, and we're going to be going to places with even worse internet. So we'll see what happens. Now, I'm going to chat about how you can get your questions answered guaranteed. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Bill, Cy Nelson, Dark Finger, Dave Verbauf, David Gilton, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Matter, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, North Space, OneStepForAnimals.org, Paul Roebuck, Rinkaidu, Richard Williams, Sean Sargent, Stephen Fowler Munley, Team 49, Telescopes Canada, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So last week, I let you know that we just released the patrons question show for the month. And the way this cycle goes is around the 15th of the month, I put out the call for the patrons to send in their questions for the new question show. And so I just put out the call by the time you're watching this. It's over on Patreon, and this is only available to the patrons, but like at the lowest level, what, $3, you can join Patreon, get access to all of the past question shows, ask your question every month to me and my producer Anton. We get to all of the questions. We answer them all, and they're much more in depth. So if you're feeling like, okay, these questions are very introductory, I'd like something with a little more meat, this is a dedicated audience of fans of space who are super into what we're talking about. They know a lot, and then they're looking to push their knowledge. So I have to do research. We have to do math, and it's a really good time. And these episodes are like 3 to 4 hours long. And now we've got well over a year of them in the backlog as well. So if you want, go to patreon.com/universe today to join up. And we should start recording the question show in about another week or so. So just, time is running out. And then, of course, then the month after that and the month after that. All right, we'll see you next time.